recording is there also. Today, we're going to talk about IP addressing, and this is one of the most important lectures here. Yes, Muhammad, I sent an email about it. I sent an email a couple of days ago regarding the quiz. Yeah, this chapter is one of the most important chapters. We're going to talk about the basis or the fundamentals of addressing, how the devices in the network have their own unique address. All right. Okay, swap. All right, so the outline for today's lecture, we're going to talk about IP addresses in general. And the IP address can be divided into two parts, a network portion and a host portion. So yeah, there is the network portion here and there is the host portion. We're going to talk about them because we will have classes of IP addresses. And each class determines which is the host portion and which one is the network portion. Then we're going to talk about public and private networks. We're going to focus a lot on IP version 4 and IP version 6. We're going to slightly talk about it. No details here because it's still a new technology, still under development. Okay, so IP address from the name address. So it gives a sense of location or labeling for the devices in the network. So an IP address is a numerical label assigned to each device connected to a computer network that uses the internet protocol for communication. So it's a numerical label, it's numbers from 0 to 9. And they are organized in a certain manner. IP version 6, you might not just get into numbers, you will have letters, but letters in the hexadecimal domain, but they are still binary numbers. So an IP address serves two main functions. So they will give an identification of the interface, host, whether it was a host or a network. And just a location gives like which device I'm targeting. A typical example of IP address, we've done that in the lab, 192.168.10.24. These numbers could be anything that ranges from 0 to 255. Sorry, my handwriting is not as its best. I'm not using that original device, but yeah, it's from 0 to 255. Each digit. IP version 6 goes for more, and yeah, the address looks like something like this. If I ask you, what is the length of IP version 4? This is 32 bits. While IP version 6 is 128 bits. So that's a difference in the length. Someone might ask, what is the advantage of IP version 6 over IP version 4? Basically, IP version 6 can handle more hosts, or you can have more addresses. Imagine how many combinations you can get with 128 bits, unlike the IP version 4, which is 32 bits. There were many solutions like virtual LANs, subnetting, that were introduced to solve this issue in IP version 4, but we're going to talk about them later, inshallah. All right, so you guys remember when we did the communications and TCP/IP, like the message will go over the transport layer, will go to the internet protocol layer, the IP layer, then to the physical layer, and so on. So here is my application data, my original message. After the transport layer, there will be some TCP header. Then after the transport layer will go into the IP layer or the internet layer or the network layer, which is the IP header. So the IP header here contains information. First, the length, if I recall, is 32 bits. You can refer to the previous lecture. And yeah, there it goes, 32 bits. So it has information, and most important part of this information are those: the source destination, the source address and the destination address. So those are the two important addresses are in the IP header. Destination. So there is the source part and the destination part. And here is the IP address for each one of them. So these are parts of the IP header, the IP address. And they follow the same format. We have 4 numbers and each number varies from 0 to 255. Let's not worry about what's on top. Some of them are the packet header, the checksum, and let's not worry about that. All right, yeah, and later, once it goes to the network access layer, we have the Ethernet header and trailer. Okay. So that's what we call a dotted decimal notation or binary notation. Decimal notation that we have the numbers from 0 to 9. Binary, we have values either 0 or 1. So IP addresses are written in a so-called dotted decimal notation. Dotted decimal notation that I'm having my values decimal 0 to 9, and they're separated by dots. Pretty much like this number here. This is what we call a dotted decimal notation. Decimal, I have the regular numbers that we deal in every day, and I have the dots to separate between these numbers. Now, why do I have these numbers? Why do I have values ranges from 0 to 255? Basically, this number is a 32-bit number. So 32-bit number, if you divide it over 4, let's say, locations, each one will have its own 8 bits. So each portion or each part of the IP address has 8 bits. Now, how many combinations you get from 8 bits is 2 to the power 8. 2, if you guys remember, and let's say in binary systems, 2 to the power number of bits will give you the number of combinations. It will be 256. And since I'm starting from 0, my number will vary from 0 to 255. And that's why my IP addresses or numbers ranges from 0 to 255 for each portion of the IP address. And you guys know that 8 bits is 1 byte. So we call this one the first byte, the leftmost part, second most part, the second byte, third byte, and fourth byte. And I will assume that you guys know how to convert from binary to decimal and the opposite. So each byte is identified by a decimal number in the range of 0 to 255. A quick look on converting from decimal to binary. If you guys remember, 2 to the power 7, that's equivalent to 128. 2 to the power 6, 64. In fact, anybody who deals with computer and IT, he knows the powers of 2 from at least 0 to 10. So 2 to the power 5 is 32, 2 to the power 4 is 16, all the way 2 to the power 0, that is 1. So if you are given this IP address here, or this binary combination, this part, and I ask you how to convert this into decimal, you have this table here, and this is index number 0, and this is index number 7, and whichever bit has a value of 1, you just take the decimal equivalent for it. So in this case, I have 1 here, so I'll get this 1. I have 1 here, I'll get the 8. I have 1 here, I'll get the 16, 32, and 128. Here, then you just add them all together and you'll get your decimal number. So for example, this IP address here, in fact, it's actually this value. 192, that's the equivalent of 192. 57, that's the equivalent of 57 in binary. 30, and here. I will not put a lot of, let's say, details into this one. I will assume that you guys know how to convert from binary to decimal and vice versa. So here, again, another technique of doing that, similar to the previous one. You just put the powers of 2, 0, 1, 2, 3, which is basically 0, 1, 2, 4, 8, all the way to 128, and then you perform the addition. And by the way, each byte is also known as octet. Octet because I have 8 bits. So 1 byte is equivalent to 1 octet. Keep that in mind. You might be asked. And the first octet is the last to the left. Second octet is the one next to it, right to it. Third and fourth octets are the other ones to the right side. All right. So similarly here, exactly this is the similar as to this one. So let's not worry about it. Okay. So IP address 192.168.100 and 225. So here is the part what we call a network portion here. This part here, 225, that's the network portion. Now, there are certain categories or certain addresses that have a meaning. Like if you have an IP address of the value of 255, 255, 255, 0, that's what we call a subnet mask. That's not an exact IP address. This is just to show which one is the host portion and which one is the network portion. So the IP address consists of two portions, network part and host part. How to know that? Using the subnet mask. So basically the subnet mask, wherever the digits are 0, in here, what's equivalent in the IP address, this is the host part. Now, what about the ones that has 255? Those talk about the network portion. So in this case, 192.168.100, that's all network portion. How did I know that's the network? Because my subnet mask 255, 255, 255 at these locations. Now the 255 is the host portion. How did I know? I have a 0 here. A special address is known as the gateway, has always a host portion of 1. All right, now here are some important things about IP address. There are 4 octets or 4 bytes, 32 bits. We have known that. Now we're going to talk about their classes. How to determine which one is class A or class B or class C. Their values range from 0 to 255, 32 bits, and it consists of a host and network portion. Every IP address must have all these features. And you notice like 32 bits is equivalent as 4 octets. So like, both terms mean the same thing. Okay, going back to converting IP address to binary. Similarly here, like forget about the title to binary, but here, yeah, it's the same exact addresses we have here, 192.168.100, 255. That's their equivalent into binary. Now, notice one important here. Here we're going to talk about classes A, B, C, D, E, and that's it. That's the 5 classes. Now, later we're going to go to something called the class list, and that class list is determined by a number that will be added to the IP address. Let's not worry about the class list for now, but just to mention that how to know the network portion and the host portion by converting the subnet mask into binary and the IP address also into binary. And you notice whichever bit that has a subnet mask equals 1, that is a network portion. So my subnets is like all ones here, then this whole portion is the network part. I have all zeros here, that's my host part. Later you will see that, okay, the subnet has zeros here. So my network portion will be this one only. So here I will have the host, and here is the network. And that's something we're going to call CIDR, or classless domain networking. So yeah, when you have zeros here, that will be not classes A, B, and C. That will be a different kind of classing or classification. Let's not worry about them for now. We will just follow the classes, the standard ones, the previously used ones. Gateway, as I mentioned, has a host portion of value 1 only. Okay, so the first one here, 1, 1, all zeros, so that's 192. This one, do the conversion. Similarly, following this table here, and so on, and then you will get the IP address and numeric domain or decimal domain. So the first one here is 192. This one here is 168, I guess, 168. The third one, and this one here, if you do the conversion, that is 1, 2, we have a 4, 8, 16, 32, and 64. So 32 and 64, that is 96, along with a 4, that's 100. So the IP address is 192.168.100, and here is the host portion. You do the conversion and it will be found easy. All right, so up till now, we know that IP address has two portions, host portion and network portion. How to know the host portion from the network portion? Look at the subnet mask. Subnet mask, the bits that are all ones, they indicate that is the network portion. The bits that has zeros, that is the host portion. Gateway is a default address that has a host portion value equals to 1. And there are some others actually that when you have the host portion equals to 0, that is for the network address. And when you have a host portion 255, that is something we call a broadcast address. Okay, so subnet mask, assigning an IPv4 version 4 address to a host requires, so you need an IP address and a subnet mask. We have done that in Packet Tracer, that when we do the IP address, subnet mask usually is, let's say, automatically will be found. Usually from numbers from 192 to 224, I guess. We'll check the, let's say, the domains later. Subnet mask will be something standard. So subnet mask used to identify the network host portion. If you were asking the exam, what is the job of the subnet mask? Is to identify the network host portions of the IP address. In fact, you can check the subnet mask using the command prompt cmd. Just put ipconfig, and we have done that also in Packet Tracer. ipconfig. Just look for the ones that has IP version 4, because showing IP version 6, just ignore them. Oh yeah, there we go. So yeah, IP version 4 address. So I have this one, 192.168.56 and 1, and my subnet mask is 255.255.255.0. So this one is not connected to the internet, this port here, because probably it's for the virtual machine. But let's look at this one here. So my Ethernet IP version 4 is 192.168.70.133. My subnet mask is 255.0. And notice the default gateway. It's exactly the same network portion, but my host portion is 1 by default. That is for the default gateway. So yeah, this is how you check your configuration here. You can use the DOS, you can use your Windows when you check the network card. Okay, hide floating from current slide, swap. All right, so network and host addressing. Using the IP address of the destination network, a router can deliver a packet to the correct network. And that's the importance of distinguishing between the network and host portions. So think about the network portion as the house or the big building. And inside that building, there are certain rooms or certain apartments. So when somebody, when the postman wants to deliver the message, he first will look at the house address. And that is equivalent to the network address. So once he is there, he can deliver the message to the proper host or to the proper apartment. But how can he tell that is the correct house? So he has to track the locations until he reaches let's say the correct location of the house. So using the IP address of the destination network, a router can deliver a packet to the correct part, because you need to connect, deliver to the network first, then you go connect to the host. So when the packet arrives at the router connected to the destination network, the router uses the IP address to locate the particular computer connected to the network. Again, go back to the example of the house that has many, or a big building that has many apartments in there. So as we mentioned, every IP address has the two parts, the network portion and the host portion. So pretty much like in here, so this is network 1, and this is host 2, and this is network 1, that's host 3. And there you go. So there's a reserved address for the network. There's network 1, address 1. Here's the router that's connected to network 2 that has host 1, network 3 that has another host 1. So this 1.1, that's the network address. While those 1, 2, and 1, 3, that's our host address. All right, so we talked about host and network concepts. From the subnet mask, you will know which is the network part and which one is the host part. So if you go and consider the following IP addresses within a network, which of the following IP addresses is wrong? So let's give them a look. You have 192.168.102. I don't see any issue here. Here are the network part is already here, 192.168.100. And the network part is 2, so it should be fine. In here, 192.168. So as long as these numbers are the same, they belong to the same network. However, if you go and check this one here, you notice that's 192.167.100. So that belongs to a different network. Okay, different network. Because the network field is not the same as the upper one, so the correct answer is this one. This is the incorrect address. So this is again assuming that you are given a network address and asking you which one of those that does not belong to that address or to that network. And here the network portion is the wrong one. Okay, now we're going to talk about how to deliver a message from one location to another. So there are modes of transmission. So there is something called unicast. From the name uni, there's like single. Unicast that you're sending from one host to another host. So reverse to one device, sending a message to another device, one-to-one. A unicast packet has a destination IP address. That is a unicast address which goes to the single recipient. So you are sending from this source to this destination. Let's not worry about that 24 here. That's civil kind of identification. Yeah, so you're sending from 172.16.4 and 1 to 172.16.4 to 53. So assuming this is the source somewhere here, sent to the router connects to the switch will know the addresses here. So this is the correct destination. The message will be delivered there. But that's unicast. Another mode is called broadcast. Broadcast means sent to everyone. And here is something unique about broadcast. Broadcast address has a destination of 255. So this is incorrect, actually. Let me just fix it. The destination will be 172.16.4.255. This is 16. So keeping that in mind, this is incorrect. So the source is a single place, single computer that sends the message to all. That's a broadcast. A typical example of this is like satellite TV. You are sending a message and you are sending it to all. Whoever receives it can, let's say, read the message. So broadcast transmission refers to a device sending a message to all devices in a network. And that's what we call one-to-all. So the destination IP address with all ones in the host portion. There you go, in the host portion. So that's why I mentioned this is incorrect. So keep that in mind. This is the typo here. Probably it will not be fixed in the slides. Refer to the recording to see this error. So the network portion is the same. The host portion will be 255. and the broadcast destination part. Then there's something kind of in between the unicast, which is one-to-one, and broadcast one-to-all, will be multicast, one-to-many, but not all. So multicast transmission reduces traffic by allowing a host to resend a single packet to a selected set of hosts that subscribe to a multicast group. So there is a certain range for that. IP version 4 has reserved this range to 24 to 239 to 55 for multicast tasks. So keep it in mind, this range is important here, because later we will see an IP address that has something between those. It could be incorrect. This range is reserved for multicast. So yeah, the source here, 172.16.4, wants to send a message to 3 and 4. So he will send the IP address, or sorry, send the message to those addresses, for example. 10.10.5, 224, 10.10.5, 10.10.5, 24. All right. Now we mentioned that there are 2 unique addresses in your domain. So assume that the network portion is the first 3 octets from the left, and the host portion is the only last octet to the right. How many hosts can this network support? First, there are certain addresses that are reserved. First, when you have that value 0, that's the network address. So you cannot assign a host with that value. 2, 255, that is reserved for broadcast. So you cannot assign a host with that IP address. So within each network, there are 3 types of addresses. There's the network 1, network address, host part equals 0. And there is the host address that ranges from 1 to 254 at the host part, or address that can be assigned to a device such as a host computer, laptop. And then there is the broadcast, where you have the host equal 255. A broadcast address is an address that is used when it is required to reach all devices. And there is also another address, but you cannot say it's reserved because you need it as a gateway, and it's assigned to a certain device in the network. So for example, in here, this router was assigned this one. So that's what we call a gateway address. That's going to be your address that connects you to the network, your gateway. So this is also reserved for the network address, but you cannot say that is assigned or cannot have that value. So you can consider it as a host or a network device that has that address. Now, other hosts, there you go. The portion here is 10, 55, 101, 12, and so on, and they are unique. So you cannot have duplicate IP addresses. Also here, the network address has a 0 at the host portion. Let's ignore the 24s at each one of them. Same thing here. So if I ask you, how many hosts can a network can have? Let's say, how many hosts? If you are given a network, how many hosts can you have? The typical answer will be 254. You have 256 combinations, but one of them is reserved for the network address and the other is reserved for the broadcast address. So you have 256 minus 2 is 254. How many hosts can a network support? That is 254. But that is only when you have the host portion as the last octet to the right. But what if the host portion is 2 octets or 3 octets? What will happen then? Things might look different. And that's something what we call a classes in IP. So IP addresses can be identified into classes by the first octet. Just looking at the first octet, you can identify which class is it. So for example, if your first octet here, the value there ranges from 1 to 126, that's what we call class A. If it ranges from 128 to 191, that is class B. 192 to 223, that is class C. 224 to 239, that is class D, and it's reserved for multitask, if you guys remember that range we talked about. Multicast, not multitask, multicast. And this one here, 240 to 255, that is class E, and that is usually for testing. So basically, if you think about it, we have only 2 or 3 operable classes. We have class A, class B, and class C. That's the usual ones that we work on. Because class D is reserved for multicasting, and class E is for testing. Well, let's talk about each one of them in detail. Let's start with class C, which is the widely used one. As I showed now, my computer, the IP address 192.168.71 or something. So yeah, as I mentioned, there are 254 hosts. There is one portion, one number, one address is gone for the network, and the other is gone for the broadcast. So the range is here for the last octet from 192 to 123. Let's not worry about this for now. So you see here, there is 192, 168, 100, and the subnet mask, all ones here, all ones here, all ones here, and this one, all zeros. That gives me the portion part in here. I have a gateway of 0, and this is the network part. So in class C, the network part is 3 octets, and the host part is only 1 octet. So yeah, the network address, something like this. Valid IP address starts from here until here, even though this is a gateway, but still a valid IP address. And this one is for broadcast. That's why I have a freedom of only 254 addresses that I can assign hosts into. All right, that is about class C. How many hosts? 254. Now, what about class B? Class B is a bit different. Class B, the only network part is only 2 octets, while the host part now is another 2 octets. That's 16 bits. So if you do the math, 2 to the power 16 minus 2, see here 16, because I'm having now 2 portions here. So that's 8 bits from this side and another 8 bits from this side. So I have 16 bits that I can assign as a host. Definitely after removing the network and broadcast portions or hosts. So in this network, it can support up to 65,534 hosts. And the range of class B is this one for the first octet. So for example, here the IP address is 172, which falls in this range, 128 to 191. So in here, network portion is only 2 octets, host portion is 2 octets. Let's not worry about the 16 here. That's what once we go into the CIDR or classless interdomain network. So similarly, that's the network portion reserved here, and this is the broadcast. Remember the broadcast, the last 2 octets will be 255. So in this case here, or the host portion is all ones or 255s. And the network is 2 zeros here. All right. Are we clear up till now? Any questions? Any questions? All right. So right after this will be class C, and as you may all guessed, the network part is only 1 octet and the host part is 3 octets. And my range here for class A is from 1 to 126 for the first octet, the values there. Then, and in this one, 200 to the power 24, because we have 8 bits as the host part 3 times. So that's 24 bits minus 2 for the network and the host, and you get 2 million and like almost 2 million hosts in this one. So for the network address is this one, and the host portion is, or sorry, the broadcast is this one. The host can have any between posts. Okay, so this one we talked about them a little bit. Now let's go into the details. How much time left? Okay, good, we have plenty. So yeah, class A is designed for extremely large networks because you have about 2 million hosts in this one. All right, so you can have more than 16 million host addresses available. Use only the first octet to indicate the network part, and the last 3 octets are for the host part. Class B, the main let's say task is for a moderate large size networks, 16 bits or 2 octets for the network and another 2 octets for the host. Class C, that is for the typical networks used. So Class C address space is the most commonly used one, as you have seen on my computer. This address was intended for small networks with a maximum of 254 hosts. Excuse me. All right. So we talked about classes A, B, C. Now we're going to talk about class D. We talked about is reserved for multicasting. So the class D address was created to enable multicasting for an IP address. So it's a unique network that direct packets with a destination address to the predefined groups of IP addresses. So a single station can simultaneously transmit a single stream of data to multiple recipients. The range here 224 to 239 at the first octet part. Then class E, it's been defined. The main job is like for testing their own research. So the Internet Engineering Task Force reserves this address for their own research. It's for testing only. It's not available for us users. So no class E addresses have been released for use in the internet. So it's reserved. Okay, there is a loopback address. In fact, if you look at the classes, the classes here, so there is a range between 127 to 100, or like the 127 range. It's not there. So that's something reserved for something called ping loopback. So to test whether the net TCP is functioning or not on the local host, first ping the loopback address. So here is for testing your local area network. So open the command prompt, type ping this one and press enter. Now check the results. You should see replies indicating success. When your computer calls an IP address, you are usually trying to contact another computer on the internet. So yeah, if let's say ping google.com, it will give you a response or something. But if you want to check that your computer itself is connected to the network and has no issues, ping this one, then you are communicating with the local host in principle with your own computer. Check that the ping is functioning well. So let's give it a try here. So it says ping 127, 0, 0, and 1. So there you go. It's working, success. Then the ping functionality is working fine. The local host is doing its job. All right, so yeah, if you were asked what is the job for this address, is the loopback for ping. Now there are certain public IP addresses, and then we're going to talk about private addresses. So unique address that is required for each device on the network. That's something we already know. Like if you want to be connected to the internet, you must have an IP address. It's not redundant. You cannot have two IP addresses of the same. So no two machines can have the same IP address. Because like there are standards we have to follow. So public IP address must be obtained from the internet service provider or a registry at some expense. Basically, yeah, like right now I'm connecting from Do. So I got this public IP address, of course, with a certain charge on that one. Now there are some private IP addresses that somebody can have their own network. So private IP addresses are another solution to the problem of the impending exhaustion of public IP addresses, because notice, if everyone wants its own IP address, we will run out of addresses at some point. So the solution for this one was to come up with something called private IP addresses. As mentioned, public networks were hosts to have a unique IP address. Now, sometimes when you have a private network, let's say, for example, let's assume University of Dubai is a private network. So they can have whatever their addresses they want, but they will not conflict with other public IP addresses in the network. And that is a solution has been found for us, that we will overcome the issue of public IP addressing or redundant or two network devices having the same IP address. So they are not connected to the internet, but they are within their local area network, may use any host address as long as each host within the private network is unique. So uniqueness has to be there, but within the private network, you can have your own network with its own IP addresses that does not conflict with, as long as you are not connected to the internet, you are still fine. So here is an example here for IP addresses here for private IP addresses. For example, if it was class A, this is the range that is reserved for private IP addresses. If it was class B, this is the range. And if it was class C, this is the other range. All right. So here is an example of public IP address. Like anybody could be connected to the internet and everyone will get its own public IP, but they are unique. But assume that you have multiple devices that are connected to the network, then at some point there will be some redundancy and that will cause an issue. The solution was private IP addressing. So here is the table of differences. This is the sake for mentioning. You don't have to memorize it. So the scope of private IP addresses. So it's meant for a local present in the network, while public is global. Your IP address is visible to all. So private IP address is used to communicate within the network, but public globally from outside the network. The format, private IP addresses, they have their own uniform manner, but in this one, it's different in terms of range. Okay, the provider here is the local network. It's Salat or Do in our case. It creates private IP addresses using network operating system. And here, the internet service provider controls the public IP addresses. Cost, they are free of cost, the private IP addresses, while the public, you can get it for a charge. Private IP address can be located using ipconfig command, while the public one, you have to search for an engine like Google. So here is the range for private IP addresses. You have the rest here. Instead of like anything aside from this range, could be global. As an example, private IP address 192.168.1150, while public IP address 17.578, for example. Again, this is for the sake of mentioning. IP version 4. So it was developed by the Department of Defense. As early as 1992, the Internet Engineering Task Force identified two specific concerns, two issues with IP version 4. So we are running out of addresses, exhausted. And the internet, the size has been increased a lot. That routing tables are getting very large. It slows down the network. So those are the two main concerns: exhaustion of addresses and the routing tables. They are becoming of very large size. The routing table here is a table that is inside the router to determine the best path the message can go to. So over the past 2 decades, a lot of research has been going on. So 2 solutions were there. So we have subnet masks and then the classless interdomain routing, the CIDR. So this is the solution here. We talked about it. It adds more improvement to the subnets, wherein here the network portion and the host portion could be determined by modifying values on the subnet mask. So the issues here, we are running out of addresses. Another solution is also as IP version 6, like add more bits to the address. Instead of using 32-bit system for addresses, use 128 bits. So IP version 6 is designed to be the successor of IP version 4 to that will be the one used in the future. It has a larger address space and you can provide up to 340 undecillion. That is like almost 340 with 336 zeros. So it supports a lot of addresses. However, there is no specific dates to move to IP version 6, but I think we are moving slowly into there. I think most of network devices nowadays, they support IP version 6. So both IP version 4 and IP version 6 will coexist in the near future, and the transition will take several years. Right now, like we see that we have IP version 6 address. Dual stack allows IP version 4 and 6 to coexist in the same network segment. The devices will run both protocols simultaneously. As you can see, if you run ipconfig in your device, you will see both addresses there. The format of IP version 6 is as follows. It's 128 bits. Now they are not separated by octets. They are separated by hexadecimal digits. So IP version 6 addresses are 128 bits in length as written as a string of hexadecimal values. So in fact, they group 2 bytes together, like in this case. So, or basically 2 bytes, 16 bits together to perform the hexadecimal number. And if you guys remember the hexadecimal numbers, they range from 0 to 15 or 000 to 1111. So yeah, 16 binary digits or 2 bytes or 4 hexadecimal digits. It has the same casting types: unicast, multicast, and anycast. In fact, so there are 3 categories of addresses. Unicast 1-to-1, uniquely identifies the interface of an IP-enabled device. So unicast, pretty much like the IP version 4, it's 1-to-1. Now, multicast 1-to-many, and IP version 6 multicast address is used to send a single packet to multiple devices. So similar to the previous one, 1-to-many. Now, anycast addresses any IP version 6 unicast address that can be assigned to multiple devices. So this one here is a bit different, that the address can be assigned to multiple devices. That's the anycast. So there's no broadcast in this one. Now the IP version 6 header, similar to the previous one, but instead of version 6, version 4. So the message, you have your data here, you have the TCP header here, then you have the IP address. The main difference here, the source is 128 bits, the destination is 128 bits. Some practical examples in real life. Network and broadcast addresses. With each network, there are 3 types of IP addresses. We talked about them: network address, host address, and broadcast address. Let's not worry about them. And we have seen that network address is reserved. So we have 2 networks here, and this network has this address, and the other network has a different address, 198.150.12.0, and the other one is 198.150.11.0. And to connect between 2 networks, you need a router. So yeah, the default gateway is 1 in both cases. And here is the network portion. And basically the router connects you to the internet. And here are the devices connected here. They will range from 1 to 245, because 255 is reserved for a broadcast, which is in here. Broadcast address is similar to the network address, but instead of 0, you will get a 255 at the host portion. Now, when you mix public and private addresses, you need a translation of the private address to the public address. So there should be a device or a protocol or a translation device or a process called the network address translation, NAT, NAT. Yeah, when you mix private to public, they have their own domain, they have their own IP addresses. Private, they have their own similar standards. It's standard to avoid overlap between private addresses and the public addresses. You need the process of translation to convert the private address into a public address. All right. We talked about unicast. I think those are redundant slides. I'll remove them now. We talked about broadcast. We talked about multicast. Okay, so in here, let's assume the practical example, you want to send a message, the broadcast domain. So in this one here, this network A will send, this device A will send a broadcast message. We'll go into ARP later, inshallah, in the semester. And the message will be received into B because it has been broadcasted. So host B will reply. Now, broadcast happened within the same network. Now, in this case, in the other case, when you have two networks, so each network will have its own broadcast domain. So when I have two networks here, and this device sent a broadcast message, computer B belongs to another network, so it will not respond. Broadcast happens within the same network. You cannot send a broadcast message to two networks together. All right.